All right, sixth grade, our objective today is to finish up talking about absolute value types of numbers, and then we're going to move on to the rules for adding integers. And it's interesting because I've had some questions from you guys so far this year in regards to what do you do if you're adding integers? What do you do if you're subtracting integers? So we're going to focus on that today and finish up our types of numbers chart. Couple announcements. First one is your Chapter 1 test will be in about a week and a half, which I told you yesterday. Okay, so not next week, but sometime the week after. The order of operations worksheet corrections, just because I have all of your attention now. I will do that a lot with homework. If I collect and grade it, part of your warm-up will be to make corrections. And that's so you can look through your work and see what you messed up on. Or maybe you don't know, maybe you need to ask me. That gives you a chance in the morning to come see me so I can kind of give you a hint to where you went wrong, or maybe you had just a little silly mistake. Also, sometimes your warm-up is going to be to check homework. That way we can get right into going over the answers and talking about it. Okay, I always change it up. So just make sure you either read the board carefully when you come in or read the smart board. I always have it in one spot, and as soon as you get in, just get to work. Okay? All right, so on numbers 1 through 13 on the homework, any questions? You should have already all checked it. So any questions on 1 through 13? Doug? You did not get to check it. Okay, check it now. Okay, well, Doug's looking at that. Anyone? Okay, what about the second part? Questions on 14 through 31. Mary? Okay, so here's the second part. Woo! Hold on. While you guys are finishing checking this, does anyone have any questions? Let me just move that up. Okay. Emma M. Okay. Number 25. Okay. Take your time checking, guys. I'm going to go over the problem. 25 is 2 absolute value of x. We know x is -7. So Emma M, what is the absolute value of -7? Good. So what's 2 times 7? There you go. Okay. Charles. Oh, I thought that was a hand. Mary? All right. So 29, we have -x minus 3. We know that x is -7, so that means we have -7 minus 3. Got it? Okay, and then 30, it's the same thing, Mary, like similar problem, I should say. -x plus 10. So -7 is +7. That's why I did that problem yesterday with the 2 pens crashing. If you have 2 negatives back to back, boom, they always make a plus. Okay? Annalise. Yes, you may. Yeah, right across. Like, just go out my door and you'll see it straight ahead. It's very easy. It's just literally a 2-second walk. Okay, anyone else on the homework? Did everyone finish checking? Okay, Doug, did you finish checking? Okay. All right, so while we're waiting for a couple people, give me a thumbs up, thumbs middle, thumbs down on how you did on the homework. And I have some challenge absolute value problems that we'll do on Monday. Okay, thank you. All right, what is, in your own words, what is the definition of absolute value? Definition of absolute value, Breyer. Okay, but give me, you're right, that's a little bit confusing, but you're all right. Do you remember how I explained the definition to you? Zach, help him out. Good. The distance a number is from 0. So we are going to walk the absolute value of -5 miles today. You could try to confuse people. So you're really walking 5 miles. Okay? Absolute value is always the distance from 0. Yes, that number is always going to be positive. What is the opposite of -3? What's the opposite of -3? Annalise? Good, positive. The opposite is always the opposite sign of whatever that number was. Okay? All right. What is a natural number? What is the first number for a natural number? And what is a natural number? Doug? Okay, yep. Justin, add to that. You say that again? Good. It's everything past 0. So like 1, 2, 3, dot, 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 dot. Is 5.5 natural? No, not natural. Nope. The very first natural number is 1. The very first whole number is 0. Yep. Okay. An integer is just like that, but it includes all the negatives. Okay. Rational. What's one thing that is included in a rational number? We made a whole list yesterday. Donatus? Yep, perfect square or true square. I like that. Charles? Good. A decimal. What else, Annalise? Good. Okay, well, that's what we're talking about right now. So do you have, can you think of something else we talked about? It's okay, you don't need to flip to it. Yep, negatives, that works. Alyssa? Good. Mixed numbers. Zach? Good. Improper fractions. Emma M? Is that what you were going to say? Okay. All right, so let's go back to that. So in your notes, go back to the types of numbers chart, or sorry, page, which I think was page, it was either 12 or 13 in yours. 13? Okay. Almost. So I'm going to clarify that right now. So a rational number is a perfect square, a fraction, a decimal, a mixed number, an improper fraction, a repeating decimal. A rational number could also be a natural whole or an integer. So a rational number could also be a natural number, a whole number, or an integer. A rational number is basically anything except for what I'm going to talk about in a couple minutes. Charles? No? Because infinity depends on how we're using infinity, which is, I know, a little bit confusing there, a little vague. Zach? Yep. So if you're making a rational decision, you've thought things out, you're making probably a pretty good decision. If you're irrational, what does that mean? Or if someone's being irrational, Briar? Right. Just do it, right? Or if someone walks up to someone and decides to punch them, that makes no sense. Your behavior is irrational. You shouldn't be doing that anyways, right? Mary, you want to add to that? Right, there you go. Irrational, I always think of it as being crazy, okay? You're not thinking through things, you're just being completely crazy. Emma M. Yeah, makes no sense. So here is the confusing definition from the book, which I want you to write down, and then I'm going to explain it. Irrational number, okay? Any real number which cannot be expressed, we're on the notes on page 13, as a fraction of p over q, or p over q is a fraction, and the denominator cannot be 0. So an irrational number cannot be expressed as a fraction. An irrational number cannot be expressed as a fraction. This is one of those numbers that does not have a pattern, that just kind of repeats however it wants. We have a lot of numbers like this. Okay, give them 1 second, then I'll let you say that. Hey, Doug, raise your hand. You're yelling out, okay? Hold on 1 second. So any real number which cannot be expressed as a fraction, which could be p over q. P and q are always integers. The denominator is always non-zero, which means it's not 0. Annalise, is this making a little bit more sense with rational? Okay. So what is the perfect example, Mary, of irrational? Yes, pi. I don't know if you guys know Kevin West. Anyone know Kevin West? He has pi. Okay, when we get to it, then you can do it. But Last year, he got up and he has pi memorized to, I think, the 100th decimal point. So, okay, maybe it's the 80th. I don't know. You guys know more than I do about that. So maybe it's the 80th, but he knows a lot. So Adam, remind me, when we really talk about pi, I'll have you say it first. Well, that's still more than I know, and probably more than most of us know. Emma M?
Well, whenever you would say pi to a teacher, you could.
Oh, wow. Mary?
My sister times 100, and I used to know it was a series one, but now I forget.
Okay, that's okay. No big deal. Charles? Adam?
Pi is a square repeating decimal without a pattern.
Exactly. That was my...
That's
Yes. So, exactly. Yes. So pi is the perfect example of irrational because, yes, the decimal keeps going, but it doesn't have a pattern. Charles took the words out of my mouth. That's exactly what I was going to say. It just keeps going however it wants. Yes, we know pi up to a certain decimal point, but it doesn't matter. It just keeps going. That's the same thing as saying, well, what if we take the square root of a number that's not perfect? Something else that is irrational is taking the square root of a number that is not perfect. So anything that is not a perfect square and you're square rooting it, when you take the square root of this, we get a decimal. It doesn't have a pattern. It doesn't repeat nicely. It just goes however it wants. It's crazy. It makes no sense. So think of irrational as not being in a perfect order. Charles? Always. If it's a perfect square, it's always rational. Yes, always. Always. Very interesting. Always. You never learned that? Always. Promise you on that. And we're going to do more work with that throughout this book. Justin? Yes, yes. That's why it's rounded to 3.14. And when we get to the geometry part of your textbook at the end of the year, we will use 3.14. Even though your calculator has a pi button, doesn't matter. My point of emphasizing pi right now is it's a great example so that you remember the definition of irrational. Okay? Adam, go for it. Yes, yes. Wow, very good. That's a natural log. Yes. You won't learn about that until Algebra 2 and Trig Pre-Calc. Wow, man, you guys are a good class. Mary. Oh, wow, I did not know that. Wow, wow. Charles. I'm not going to say yes or no, but I would probably say no. But don't quote me on that. You can, but here's the problem. The calculators are probably outdated with how many decimal points that we know up to pi. Do you know what I mean? So it depends on, right. Well, no, actually, it probably keeps going. It just doesn't show us it because the screen's only so big. But I would say no, that it's still irrational, is what I would say. Mary. Right, because the calculator can only fit so many. Okay, let's go. We got to get moving to the next part. Okay, next definition is real number. A real number is anything that we talked about. Positive, negative integers, rational, irrational. A real number is anything we've talked about. Positive, negative, rational, irrational. So it kind of sounds weird that we're talking about real numbers here. Positive, negative, rational, irrational. Well, that's because there's something in math called an imaginary number. So no, it's not like having an imaginary friend. There is such thing as an imaginary number. Yes, we can see it. I will vaguely and very like surface level explain what it is and what it's used for. It's too advanced for this course for me to get into a lot of details, but next year you should learn about imaginary numbers. Charles?
Is an imaginary number 12?
No. Doug?
When I years ago and I was stuck using
Okay. Okay, no. Mary?
so numbers and natural numbers are
Everything's real because whole numbers and natural numbers are all positive integers. Okay? So that's why I put up here, well, the book actually, this is their definition. Positive and negative integers are real. Rational and irrational are real. So basically, everything we've talked about so far is a real number. Right, is a real number. John? Okay, I'll get to that. I'm getting there. I just want to go over the overview first. Zach? I'm getting to that. Annalise? No. No. Because 1.3 repeating is rational. And that's not even. So no, it has nothing to do with even. The square root of 25 is rational, but that's not even. Okay, Mary?
would a negative decimal be imaginary?
No. Okay, here's what an imaginary number is. So put next to imaginary number, I. The letter I we use to represent imaginary numbers. Something is imaginary when you have a negative inside the square root. You cannot take the square root of a negative number. Why? Why can we not take the square root of negative 25? This is going to make you think on a Friday. Why can we not take the square root of a negative 25? So if you have your hand up, make sure you have a good answer. Go ahead. You want to try, Alex? Well, it could. So if we took that and I said, all right, if I told you this is not true, if I told you the square root of negative 25 is negative 5, why is that false? Jeremy?
Make up a square. Because if there's nothing to make a square, how do you get a square?
Okay, kind of. Charles? You mean, say that again. Say that again. Okay, good. So, correct. So, negative 5 times negative 5 is not negative 25. 5 times 5 is not negative 25. So, you are not allowed to have a negative inside a square root, which leaves us with the definition of imaginary is I, which is the representation for an imaginary number, is equal to the square root of negative 1. This is just very general. Doug, just put your hand down for now. Very, very general, okay? So, yes, they exist. Really, really small little application here. Well, what do I need these for? Why do these exist? In Algebra 1, when you learn how to graph a parabola, which is a quadratic function, this might be a lot, but it has the x-intercepts of the graph are imaginary because they never cross the x-axis. This is the x-axis. They will never touch it because they have imaginary x-intercepts. That's the application. You won't learn this until next year. If we have time this year, I'll show you because it's pretty cool. Mary? Correct. When it's a negative inside a square root house. Yes. Annalise? Okay. Basically, for now, because that's way above the course where you need to be, all you guys need to know is you cannot have a negative inside a square root house. So all you guys need to know, you don't need to know why, because this is not even in your book. I just add it so you guys know. Just remember, there's no negative inside a square root house. Okay, Emma? Uh-huh. X-axis. They don't exist because they're imaginary. So they're floating up somewhere because they're imaginary. That's way above the book that we're using, but I like to show you guys some harder stuff. Go ahead, Doug.
If you do like negative 25, would it exist?
Correct. Correct. Okay, so let's go on the next page to the types of numbers chart. This will help. Those of you that told me you were confused, this will help. So go to the handy dandy types of numbers chart that I made. Okay, so now that you have an overview, I know you guys do not have it mastered yet. And remember, this course is challenging. You are not going to instantaneously learn everything because you're 2 years accelerated. Okay, I'm pushing you guys this year, so be patient. Once you do the homework, after we do examples, you will get a better handle on it. Adam, what's up?
What's the trick to finding out the split?
You're ahead of me. That's chapter 9. All right, types of numbers chart. Here it is. What goes in the very, 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 very tiny circle? Raise your hand if you know. No yelling out, please. What goes in the very tiny circle? Donatus, you with us here? Okay, no sleeping, please. Emma M. Nope, because everything is real unless it's imaginary. Zach? No? Charles? Nope, those go by itself. We don't like this. Matt? You're getting closer. Justin? Natural. Okay, everyone put natural in that little tiny circle. Natural numbers goes in the little tiny circle. The reason is natural numbers is the type of number that doesn't include a lot. So we know that a natural number starts with 1. It's nice, and it goes up all the way to infinity. Jot these notes down. This will help you. So natural starts with 1. It goes up. It's nice. Okay, what goes in the outside circle? What goes in the outside circle? Briar? Okay, you had your hand up. Sean? Whole. Good. Okay, a whole. A whole number starts with 0. So we have 0, 1, 2, 3, etc. Is a whole number a natural number? Is a whole number also considered a natural number? Charles? Right, except for 0. Okay. Is a natural number always a whole number? So can a natural number always be categorized as a whole number? Emma M. Yes. Why? Good. So from the inside out, this little tiny bubble can always be classified as all of them. Okay? A whole number can always be classified of everything else around it. That's how this little chart works. So this should help you to learn the types of numbers a little bit better. Okay? What is on the outside, Matt, of whole? Good. Integers. I'm going to put integers up here. An integer goes from negative infinity to positive infinity. It includes 0, and it includes all the negatives and all the positives. So an integer goes from negative infinity to positive infinity. It includes all the negatives, all the positives, and 0. All right. Mary, what goes next? Go ahead. Yeah, why? Good, so I'm going to put a pi there. Yeah, irrational goes in its little bubble, and I'll explain why in a second. Okay, what goes after integer? So what goes after integer? Donatus? Good, rational. So I'm going to put, hold on. Yep, I forgot to type it. Rational goes above an integer. So I'm going to write for rational. A rational number is a natural, a whole, an integer. And we're rewriting this so you guys learn it. It is also a perfect square. It is a fraction. It is a mixed number. It is a repeating decimal. So I'm going to put a couple examples here. So a natural number is a natural, whole, and integer. It's a perfect square. It's a fraction. It's a mixed number. It's a repeating decimal. I think I got them all. So a rational, I got it. I just wrote an example, Charles. 3.5. Oh, improper. Thank you, thank you, thank you. Improper fraction as well. Annalise. Yes, thank you. Oh man. I thought I had them all. Doug, do you? Okay, hold on. Wait till we get to it. Hold on. So rational, there's a lot of things. All of these terms, natural, whole, and integer, are considered rational. So all of these terms are considered rational. Keep that in mind. Okay, do you guys have questions, or is this the next one? Question? Go ahead.
What's it say about the fraction?
Perfect square. No, this is a repeating decimal. Okay? 4.4 repeating. Remember, if the hat is above it, it's a nice repeating decimal. Charles, question or next one? Okay, hold on. Adam, ask your question first.
I thought that you had real numbers.
Okay. All right. Okay. Doug, what's the next one? No? Matt, real. Here's the one I forgot to type. My fault. That last part of the circle. Okay. Well, I meant the outside circle. Okay, the outside circle is real, which means I'm just going to put arrows. Every single thing in this chart is a real number. Every single thing inside this chart is a real number. Sean? Yes. Irrational is real, it's just crazy. If numbers can be crazy, irrational is crazy. If that's possible for numbers to come to life. Annalise? Yep. Rational is any number unless it doesn't have a pattern. So the only thing that rational is not is pi and anything that is not a perfect square. So there's two things that can be irrational. Pi or something that is not a perfect square. Right. Every single thing else, Annalise, is rational. Well, hold on. Perfect square, not 5, but the square root of 25 is perfect, which is 5. So if it's a perfect square, it's rational. Mary?
So rational can be integers or numbers.
Yes. Yep. That's why I put an N, W, and an I up there. Because a rational number, think of the circle chart here, guys. Rational number is outside all of this. So that means it includes all this stuff. So a rational number includes all this stuff. It's like hugging everything. It's around it. Just like real encompasses and is around all of this, which means all of this is real. You know what I mean?
So the one outside is also copies the one inside it.
Yeah.
And then it's real.
Yes. Yes. I guess I should have explained the circle chart to you guys. You've never seen a chart like this? Some of you guys. Same with any circle. Whichever one is around it, it includes everything that's on the inside. Donatus. No. Oh, I see what you're saying. No, anything that's not a perfect square is irrational. Okay? That's a good question, though. Emma M. Okay. Any other questions? Sean? I'll get to you. Because if you have a long decimal, it probably, I'm guessing, has a pattern. If it doesn't have a pattern, then it's irrational.
Okay, so like 2.4, you just kept on going on without the pattern of the irrational.
Correct. Correct. So just think of irrational as no pattern. Adam. What is E? You'll learn about that in Algebra 2. It's a log. Adam, I cannot explain that in 5 minutes. That would take me 40 minutes to show you what that is, for me to teach it the right way. Okay? Annalise.
So like fraction and decimals and square roots, are they?
No, an integer is always a nice number. So all negative numbers, all positive numbers. Okay? Doug. Okay. Go ahead, Doug. Okay. Imaginary goes inside this little circle here. So all I want you to do, for imaginary is write down I is equal to the square root of -1. So we use I, which is an imaginary number, to represent that there's a negative inside a square root. Charles. Can't take the square root of 0. So no. You cannot take the square root of 0, so no. It's not an imaginary number. No. You just can't do it. It's just nothing. Right. It's real. I mean, 0 is real. Right. But it's not imaginary, but it's nothing. You know what I mean? Okay. Annalise. -1 is real. Okay. This is just like an overall example, which just tells us that if you have a negative inside a square root house, it's imaginary. So we could have square root of -40, imaginary. Square root of -10, imaginary. This is just generalizing what an imaginary number is. Does that help a little bit? All right. Okay, I want everyone to look at the bottom of your paper. Do you see where that little chart is? Let's do this together. Okay, so square root of 24. What do you think? What can we check off? Square root of 24, what categories does it fall into? Briar? Okay, what else? No. Mary, help him out. Okay, good. Irrational. Mary, why is it irrational? Good. It's not perfect. Good. Doesn't have a pattern. It's not perfect. Justin? Nope, it's nothing else, just that. Because the square root of 24 is going to be a decimal. When we take the square root of 24 in our calculator, it's a decimal. The reason is it's not a perfect square. Square root of 25 is 5. Square root of 36 is 6. But that one does not have one because you can't use the same number and multiply it to get 24. Annalise? Something times something. So multiplying the same number. Right. Because 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. You with me? So any number you multiply by itself, the product of that number is always a perfect square. Okay, so you guys didn't really ever learn the definition of perfect square, and I assumed that. All right, my fault. Does that make more sense? Thank you, Annalise, for asking that. Doug, question? Go ahead. Yeah. Yeah. No pattern. It just goes however. Yep. Emma M. Okay. Square root of 100. Emma M. What categories does it fall into? Not done. Making you guys think on a Friday. What is it? You guys are all like, Zach, what do you think? Why? What is the square root of 100? What times what gives you 100? Don't yell it out, anyone. So ready, here's a hint. 9 times 9 is 81. What times what gives us 100? What's the next number after 9? Okay, what's 10 times 10? Okay. Oh, it's a Friday. I figure I'll help you a little. Okay, so the square root of 100 is 10. So 10 is a real number, a rational number, an integer, and a whole number. Do you guys understand that now and see that? Okay, if your hand is up, are these questions? Donatus, go ahead. What's your question? Okay, no. Who has a question? I'll get back to you. Jeremy.
You said that which one would it be? Wouldn't it have to be integer because
It is an integer.
you can't have a rational number and integer?
You can. Oh, no. You cannot have, oh, I see what you're saying. You're doing process of elimination. Right, it can't be both of these. It has to be one or the other. Right. So if it's rational, it has to be, and well, not has to be. Okay, but if it's rational and it's a fraction, it's not going to be an integer or a whole. Do you know what I mean? An integer and a whole number has to be a nice number.
I was just saying since the irrational number.
Oh, yeah. Okay. Yep. Okay, who else had a question before we go to the next one? Zach, question? Yeah. No. If it's a real number and an irrational number, it cannot be a whole number because an irrational number is a crazy number that doesn't have a pattern. Remember, a whole number and an integer are nice numbers. They are not decimals, not fractions. Okay? Okay. Let's do one more. Well, actually, two more. Negative square root of 81. So, Donatus, where does this fall? Okay. Awesome. That's really -9. So perfect. Annalise. The negative is in front of the square root, not inside of it. So it's really just -9. Because the square root of 81 is 9, because 9 times 9 is 81. Okay? Yeah. Okay, let me ask you this. Square root of -100. Now the negative is inside. I added these two. Alyssa. Say that again. Good. Imaginary number. So I'm just going to write down imaginary. Okay, so if the negative is inside, it's imaginary. If it's on the outside, it's not. All right, I need everyone to open up your homework packet to page 18. So open up your homework packet to page 18. Okay, it looks like this. So open up your homework packet to page 18. It looks like this. Some of you guys really need to go over your definitions of types of numbers. So I'm going to give you something to help you. Okay, it's going to take practice. Okay, every year this just takes practice. Okay, so page 18 looks like this. Everyone found it? Okay. Here's what I want you to do, not now, on your own. Do you see how it goes? Natural, whole, integer, rational, irrational, real, imaginary. At the top, underneath each of the terms, I want you to put like what the numbers are. For example, underneath natural, you would put like 1, 2, 3, ... Do you guys know what I'm saying? Like kind of use the definition and put some little hints for you so you know how to categorize this. Just like we did on the chart, you'll start with -8 and say, okay, well, what categories does -8 fall under? Put a little X there so you know which ones it falls under. Look at the bottom of the paper. The bottom of the paper, count up 5 numbers. Look at the bottom of the paper, count up 5 numbers. Okay, ready? The 5th number from the bottom has a 0.1. Darken that decimal point so that you know it's a 0.1. It's kind of hard to see. Okay, any questions on how to do the chart, what you're doing? Annalise? Go ahead.
Or even a kid, like, on a test, maybe they can't put
No. Nope. You guys need to learn those. That's why we're practicing this, because you're going to have to know how to categorize each type of number. Okay? We're going to do plenty of practice in class, though. You guys will be fine. Take your time on your homework, though. Use what I said, the strategy of writing notes at the top, so it helps you to learn them. Okay? All right. It's time to go. So if you don't need your calculator, put it away. If you have